Welcome to Cone Blue Pottery, where the focus is on research and development of ceramic glazes. Currently, glazes are fired from cones 6 to 10 in oxidation, but I'd really like to test some in reduction. In this video, I'm converting a used electric kiln to a propane gas-fired kiln. The first step is removing the electrical box and the kiln elements. The next step is cutting gas inlet and outlet holes on opposite sides of the kiln. I used a hole saw with diameter 1 inch larger than the burner size. Hole saws are typically designed to cut wood. I had to look a bit to find one to cut metal. The hole saw only cuts 2.5 inches deep, but the kiln brick is between 3 and 4 inches. So I had to scrape the soft kiln brick down to the level of the cut in order for the drill to go the entire way through the brick. The choice of burner is very important. I chose a Ward B2 Venturi burner, well matched for the BTU requirements for this small kiln. The machined Venturi burner has much better control than a cast raku type burner that's oversized for this small kiln. See the difference yourself in this short demonstration. I designed a bag wall to direct the flow of gas up to the 2 shelves with the test tiles. I made the chimney using a modular design so that I could take the kiln apart and bring it inside for storage. Here are 2 short videos on chimney design and flue and damper construction. Here's the finished kiln with 6 chimney modules. I attached thermocouples to the main chamber of the kiln and to the top of the chimney. And I used an Econox oxygen sensor for its higher resolution. Time to fire up the kiln. Small kilns like this can heat up very rapidly. It took 5 hours to reach cone 8. I adjusted the primary and secondary air for the burner as well as the damper opening in the chimney in order to go back and forth between oxidation and reduction. So as a result, no specific profile was followed for this firing. The kiln cooled overnight, and the next morning I unloaded the test tiles. The kiln was rated to cone 8, and that's as high as I could go. The next time I'll aim for cone 10 by adding extra insulation. The iron oxide containing glaze showed signs of reduction and reprecipitation. The copper oxide containing glaze shows a range of reduction values. The red color is indicative of reduction to base metal. This was a successful firing to cone 8 with a high level of reduction. I'm very happy with these results. I'm looking forward to testing new glazes in redox environments. Until next time, thanks for watching.